Alright, today in this video we're going to be discussing about statistics and the basics of what is statistics. Why do we bother? I think I will puke if I have to hear another, oh, we did a test to see, can anyone tell the difference between the off-brand version of 409 cleaner and the regular one or whatever? Or the taste test to see if the new Shasta Cola tastes better than the other blah blah. Nobody. Or my all-time favorite ones are things like, oh, did you see the statistics about this guy that your team traded for, Jay? I don't care. Okay, baseball is one of my favorite things on the planet. Statistics is probably is in my top 10 as well. You put them together, you'd think it'd be better. It makes it worse. Okay, I used to work with this guy. He used to drive me bananas. Come in every day. Did you see the blah 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 sabermetrics blah 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 and so's blah blah war? And I'm like, dude, what are you talking about? He's like, don't you like it? I'm like, no, it makes me sick. So there is a reason to do statistics, and so there's things that we can deal with them. Obviously, medicine comes to mind. Anything to do with agriculture. I know this because, obviously being a former farmer type person, that's kind of a big deal. But you go to the best statistics schools, they're almost without exception at the biggest agricultural schools. Let's test this feed versus that feed. Let's test this, fertilizer versus that fertilizer. This blend of wheat versus that kind of wheat. Let's talk about this versus that. Always. What are the things that make the biggest difference in our wheat crop or our corn crop or whatever it happens to be? Anything along these lines, it's huge. In your garden as well, right? Does Miracle-Gro better? Is it worth the extra money to put on Miracle-Gro as opposed to Walmart brand? Okay, marketing is key. So do we need to know? Is it better or worse? Does it matter where the shelf space we are? Does that have any impact on it or not? Does our commercial do a better job of selling our product? How do people perceive our product? Any number of things, right? These are just some of the biggest ones that come to mind. They're by no means all of them. I work in education. I get to hear all the time about how this method of teaching or that method of teaching or this curriculum versus that curriculum. And of course, what does it mean? Well, they pass a certain test at a higher level. They're more successful, quote unquote, whatever that means. These are some of the basic procedures of it. So they all statistical studies have the same basic thing in mind. So you have a population of people, a population of something. These are all the subjects being tested. Now, it could be third graders. Okay? So it could be third graders nationwide. Well, Jiminy Christmas, that's a lot of them. That's right. So instead of dealing with all of them, we will take a sample. And a sample is a representative proportion, or representative, I can't write and talk at the same, representative, that's key, representative portion of the population. Okay, representative in that I didn't choose the best of the best. I didn't choose the worst of the worst. I chose a smattering of everybody. Okay, I didn't choose all rural schools or all urban schools or all suburban schools. If I wanted to talk about all third graders, I would have chosen a sample that would have taken into account everybody. And in the same basic proportions. I wouldn't have overloaded one side or the other. Okay, we'll talk more about that as we go. Okay, there's a whole science all about. There's a whole part of statistics in terms of how do we sample. Okay, we're not going to get into that a great deal. We're going to talk about some general basics of it. Okay, but we're not going to get into it too depth. Again, you can take whole classes in just sampling techniques. But in this population, you're interested in some part of it, what we call a parameter. This is the characteristic we are interested in. Okay, so specifically, it could be the average yield of a certain kind of tomato plant, or it could be the average number of hogs that this certain breed has. It could be the average test scores, using this curriculum and then using that curriculum. Okay, it can be a lot of things, and we'll talk about that a little bit more as we go. But in order to study this, we want to know about the parameter of the population. So we take a sample and we compute the statistic. So the statistic is the same characteristic as the parameter. Okay, but figured off of the sample. Okay. Now, why do we do that? Well, there's too many people to study everybody, so that's why we take a sample, right? There's too many people out there. There's just too big a pop. I mean, like, if you want to know the amount of food the average ant eats in a day, how many ants are there in the United States? Who could count that high? Could you catch them all? It's physically impossible to do that. So you would take a sample of a bunch of different, ant colonies, I would guess, and sample a bunch of those little beggars and see what they do. I don't really know how you would measure how much they eat, but you get the picture. So it would take a sample and it would make sense to you. You wouldn't need to do all of them. In fact, it's not physically possible most of the time. Okay, obviously, if you have 5 tomato plants in your backyard, you're going to sample from all those bushes. However, you're going to use all those bushes. However, that's 5 plants out of all of the best boy variety of tomato plants there are in the entire world. 5 is kind of a small amount. So the fact that you grew those 5 plants in your area, in your garden, may or may not, they may produce a lot better because you spent all this time buying all the best compost and the best manure to work into the soil and the best this and the best that, and you're out there every day talking to them, versus other people that just grow the things and they put them in wherever they fit in, and maybe they get some sun, maybe they don't, they're in an apartment window, so yours could look really good, yours could look really bad, again, they're just the 5 that you raised there, so it's not all of them worldwide. You personally might think to yourself, I grew 5 tomato plants, therefore I took the entire population. You took the entire population that you have, but that is a subset of all of those tomato plants. Okay? So the thing to remember is this. You are interested in the parameter of the population. By the way, only God knows what it truly is, right? And He's the only one that cares. I don't care. I just need to know somewhere nearby so I can make an informed decision. For instance, Miracle-Gro does a better job, and I can show that it does a better job. Therefore, that's the brand of fertilizer that I want to use. I don't need to know what the exact figures are. I just need to know it's better than this other one. Okay, and I need to show it beyond a doubt that it is. So again, I'm interested in this parameter of the population. It's unknown, and by the way, it's unknowable in actuality. So I take a sample. Oh, for crying out loud! I turned that off. I thought. Take a sample and compute the statistic. One moment, please. And then use the statistic to make a statement about the parameter. Now, when I say a statement, I could say it's a statement and then just stop. But usually it's a statement that I'm then going to use to make a decision. Okay, so that statement usually comes with the idea of a decision. It's nice that this tomato plant does better than these tomato plants. What are you going to do about it? I'm going to start buying them. Or the idea that I've always used Miracle-Gro, but after doing this test, I realized that Fred Meyer brand is just as good a fertilizer for my plants, and it's cheaper. So what's your decision? Well, I'm going to start using Fred Meyer now. Oh, cool. Or here's one of my favorite ones. You do all the testing, perhaps, and you get down to the end, and then you're like, that's the best one. They don't really sell it around here. It's kind of a pain. So yeah, it's a little better, but by the time I buy it and ship it here, I don't really think it's going to be that much. It's not going to be out more money. Maybe I buy the one that's closer. So in other words, the whole idea here is to make a decision. Okay, that's the thing. That's a different thing about statistics than about any other branch of mathematics. It's not about computing it. Yeah, you got an answer. Isn't that neat? Not really. What are you going to do with that answer? That's the key. Okay, so what we'll talk about next is the idea of sampling. And we're just going to get into it just a little bit. The idea here is you want a fair and honest representative part of the population. That's a big deal. We want no bias. Okay? So you often hear in terms of when you take samples, you hear people talk about cherry picking. Okay? If I wanted to make my classes look super awesome, I could only choose the best kid. I could do that. I could just go and just choose the best students and go, hey, look at that. Isn't that great? I'm awesome. I could also show how lousy they are so that, hey, look, my classes are really bad. So therefore, I need more money. I need more, materials, more time to plan. You should talk about how wonderful I am because I volunteered by picking the worst of the bunch. But in reality, what I want to do is I want to pick a representative sample. The same thing goes when you're talking about, you don't want to pick the best, you want to pick the worst, you want to pick a value that makes sense. This introduces bias because I can make the data say what I want it to say. Okay, so we are going to look at several different types. There's the classic, what we call simple random sampling. That is the idea of you just reach into a hat and select a name. Okay, it's very simple. It's completely random. And as long as there's enough, people in the hat, quote unquote, then it's going to be fairly random. Obviously, if there's only 5 people in there and you take 3, it's not that terribly random. I mean, it is selected randomly, but there is going to be a bit of a bias in that the more you take out, I have a better chance of being selected at that point. Okay? Versus if there was, say, 10,000 names in here, hypothetically, and you reached in and selected 5 or 10 of them out, well, it doesn't really change my probability of being selected. It's pretty darn random. If it was the entire population of the United States, 300 million or thereabouts, 20 million, whatever you believe now, and you took out several thousand, that's diddly squat compared to the entire amount. Okay? Obviously, no one just reaches in and pulls out of a hat, okay, when it comes to sampling. But that's the picture that you see. Obviously, you'll have a computer that's selecting random numbers. The computer could be doing it. Computer could be drawing people out. You'd have a computer that actually calls people randomly and says, okay, would you take this sample for us? But it's the idea that it's just you just being picked. Everyone has just as good of odds of being picked as another. All right. So if I wanted to do something like this at the in the school district, and I wanted to my superintendent wanted to interview some people, some kids at the all grade levels. Let's say there's, close to 3,000 kids in our district, 2,800 probably, something like that, I'm guessing. And you wanted to select 10 or 15 of them. You could have the computer just spit out 10 or 15 of them. Boom, done. Okay, that was easy. It could be the same for every one of the classes. It could be a different thing like that. For instance, he could want to know, what about K to 3, 4 to 6th graders, 7 and 8th graders, high schoolers. Each of these are already set out boundaries, kind of junior high, upper grades, lower grades, high school. They are already in what we call strata. So we call this stratified sampling. So they're already in different groupings. They're already in different strata. So in this group, you would take random sampling of this group, take a random sampling of this group, and so on and so on. These are all fairly equally distributed, fairly equal size-wise. Obviously, they are not the same. That's 4 grades, that's 3 grades, 2 grades, 4 grades. So because of that, I say they're fairly equal, but you're like, well, we should pick a few less junior hires because that's only 2 grades. And we should pick more high schoolers and more K3 kids because there's more kids in those grades. More K3 than high school, even though the same 4 classes, because you get more dropouts with them at the high school. It's the same idea if you do urban, the inner cities versus suburban, your Beaverton, Hillsborough types versus, your rural types, St. Helens and further out types, right? Nationwide, what is this, 5% or something? It's tiny, so you wouldn't want to take a ton of people from the rural communities because that would skew your sample. It would skew your sample because they would be, whatever their opinion is, you'd be overweighting their opinion. Okay? Suburban, maybe it's 50% suburban in our country now and 45% urban. I just made those up. I don't know. You could look it up if you're interested. But if that were true, you'd want to make that same basic percentages so that your answers come out correct. All right, that's better. And so the stratified sampling is probably one of the key ones that we do as statisticians. Across the board, there's many, many different kind of strata like this. That's a classic. Your obviously male, female kind of a thing. Obviously, you might want to break it up. They're already in those stratas. You got smoking, non-smoking. It's the idea that I want some smokers and I want some non-smokers. Okay, take some from this group, take some from that group. You wouldn't want to just overly populate it with non-smokers, especially if the topic that you're doing has to do with smoking things, right? Or maybe smoking legislation or any number of things. You'd want to do it in such a fashion that you're getting a representative of the whole population. Okay? If you went out and cherry picked and got a whole bunch of smokers and asked their opinion about the latest non-smoking blah blah ad campaign, it would come back like, maybe 75% are against it. And you're like, wow, I didn't realize there's all this ground support, groundswell against this legislation. Well, there is in the smoking campaign, perhaps there are. So you need to be careful of that, okay? That's just it's one of many examples where if you're not careful, you can introduce bias into there. You can also do it on purpose to make your statistics lie for you. So just be aware of that. Now, when we go into these deals here in the sampling, okay, that again, stratified is probably the most common one. There's a couple of other ones that we just, we mention that are kind of nice, but in reality, for most of us, systematic sampling, for most of us, we aren't going to be going out and taking samples, per se. Once in a while, you'll see them in your job, and maybe once in a while, it'll seem semi-arbitrary. One thing I remember when I was a kid, probably in about 86, maybe 85, 86, I remember, and of course, I knew nothing about statistics at this time. In the old days, in the farm program, they would come out to your field and they'd section off a piece of ground randomly. And they'd do this all over the field. So the idea of they're not sampling the entire field, they're simply laying off a piece of ground. And I don't know for sure, so don't quote me on this, but I think it was something like 10 feet by 10 feet, so 100 square feet. So you're like, well, Jay, that field's 250 acres. That's right. So this 100 square feet out of 250 acres isn't very much. So they do 8 or 30 of these things, however many they did at the time. This was for the federal government would come out to do this. And what they do is they lay a piece of rope across the field. And this rope had knots on it like every foot. All right, which, I don't know, something along those lines. And what they would do is they'd come along here and they'd look to see how many pieces of stubble and stuff were touching these knots. And it would used to just drive my dad crazy. And at the time, I didn't understand. I totally get it now. But at the time, I didn't understand it at the time. So there would be straw on all sides of these knots, touching it. Okay, this one, look at that, didn't touch the knot. It's so close, but it didn't touch it. Anyway, they would come through and they would only count the straw that was touching on one side of the knot, which seemed rather arbitrary at the time. But they would tell you ahead of time, like, I'm only going to count the straw on the left-hand side of the rope. And that used to drive my dad nuts. He's like, yeah, but there's stuff on the other side. But the idea here is if you tell me ahead of time, I'm only doing it on the left side, then I can't look at the rope and go, yes, well, I think the right side, let me add some more straw here. I think the right side is the one I'm going to use because it's clearly superior to the left side. You see that? And so that you can't do that. If you did that, that would be cherry picking. So what they did was they had a system. And their system was, I'm only going to choose, and they would lay it out ahead of time, I'm only going to do the left-hand side of the knots. And to the untrained person, it's semi-arbitrary. It is, but what it does is it avoids any bias. Okay? Another way of doing this, so that was one I learned about as a kid, and it wasn't until I took statistics in college, I'm like, oh, that's why they did that. Because they didn't want to throw the rope down and go, well, the right side looks better, let's count that side. Or, we don't like Ron, we're going to count on the left side, okay, and then try to screw him or something, okay? So it was a way better deal. A similar deal might be this. I just went to Walmart this morning. It's a Tuesday morning, and I'm usually working on Tuesday mornings, but it's during Christmas, so whatever. I had to go pick up a few things, and I forgot that Tuesday is Senior Citizens Day. Oh my goodness, there's a lot of senior citizens there. But if you were standing out front and you wanted to take a sample of people, get their opinions about whatever, and you went there on Tuesday morning, you would get just all kind of different opinions than if you went in the middle of the afternoon on any other random day of the week versus Saturdays versus any other day of the week, because different times of the day you're going to have different clientele there. Okay? So when school's in session on any other morning of the week, you're going to likely see maybe more moms maybe there after they drop their kids off at school. Tuesdays, Senior Citizens Day. I completely forget about that until once in a while I run in there on a Tuesday like during the summer and I'm like, oh boy, here we go. But I'm already here, so I stay. Versus, on the weekends, it's a whole different clientele. So it kind of matters. So what you do is obviously you don't want to pick the same day, and you don't want to just randomly pick, I'm only going to go on Tuesdays to Walmart to get my data. I want to make sure I'm aware of these things. I want to make sure that I don't schedule it for a time when there's only going to be certain sort of people there. Okay, another thing that comes up is this. When I stand out front of Walmart and I'm going to ask questions of people, hey look, here comes a Hell's Angel biker guy out. Yeah, he looks scary. I'm not going to talk to him. No. Well, great. You're going to get no opinions from people that scare you. There's Jay Groom. He's a scary-looking weirdo and doesn't look very nice. I'm not going to talk to him either. Oh, okay, cool. Here comes a mom. She looks very friendly, but she's got like 6 kids dragging along with her, and I don't want to bother her, so she's going to go by. Here comes that old guy, but he can't even hear his wife. If I try to talk to him, I'm not going to be able to. I'm not going to talk to them either. What you end up doing frequently is, if you don't have a system going in, you end up doing what is convenient, we say. A convenience sample. That is the idea of, that guy there looks friendly. That lady looks nice. Here, this lady came over and even said hi to me, so I'm going to interview her. And what you end up doing is you end up introducing bias simply because you only ask people that don't scare you. They look like you, perhaps. Maybe you think to yourself, maybe you're a person who thinks, I'm going to try to go over the top to make sure that I don't put any bias into this. And therefore, I'm going to make sure that I ask more people of this nationality or more people of this color or whatever. Okay? Or maybe you think to yourself, I'm going to look for more people that look like this or like that. And what you end up doing is inputting more bias in than if you'd have just left it alone. And so another way around that's similar to this knot situation is you could just say, I'm going to ask every 5th person. Okay? Or 6th person or 7th person or 3rd person. One time I said that and this lady got in her head that I meant literally you could only do it with every 5th person. But you would have this idea that beforehand, I am only going to ask every 5th person out the door. So, nice person, scary, nice, Great. I could ask that Hell's Angel guy. Well, here goes nothing. Okay. And so, you have to get out of your comfort zone a little bit. But what you do is you end up, because it's the luck of the draw who's coming out, you are asking people, you're getting more of a cross section of who's actually there, as opposed to just picking and choosing people, in this case, who you'd feel comfortable going up and accosting them to ask them about how they feel about, whatever. Okay? So another way convenient sampling works, this one I see all the time at the high school. I have a stats class at the high school, and you send them out. I always love to do this. Just let them see what they come up with when they first do it. People, and so you have them take samples of just different things, or not samples. You have them go out and ask questions and get some feedback. So how'd you get that? Well, I was in my third period class, and there was nothing going on, so I just asked a bunch of people. Oh, what's your third period class? Well, it's, whatever it is, and they're in a class with people that are exactly like them. It could be a shop class. It could be maybe they're in a AP biology class. So the idea is that they're not getting a sample of across the board people. They're getting a lot of people that are just like them because they're in the same classes, so they tend to group very similar likings and stuff. And another way of doing that, a lot of times kids will just go, well, I asked a bunch of my friends. Well, you think you're friends and you have like very similar opinions on a lot of things? Well, yeah. I'm like, so are you getting a cross section of everybody in our school, or what's going on around the States? Well, no. See, that was convenient, but convenience is usually a bad thing for us. Okay, so systematic sampling is another way of pulling names out of a hat per se, except I don't know everybody's name in Walmart, so I can't draw a name. So what I do is I come up with a system, a plan, and I'm just going to ask every third person, every sixth person, whatever it is, so that I'm not going to be putting in any sort of bias at all. Okay, and so those are just a few different types of sampling. There is another kind that we don't talk about in this class, but it's used. I kind of want to say fairly often, in that. In the big cities, oftentimes, instead of going to, instead of looking at people, you look at like neighborhoods, and so you'll sample neighborhoods, and in those neighborhoods you'll go in and sample, like, say, a couple of big apartment buildings, and then you'll sample like floors off of those buildings, and then just a few people off of each of those floors. It's the idea of what's called a cluster sample. So it's kind of a cool deal in that it's a faster, quicker way to do a non-biased approach in a big city like that, kind of a thing. Excuse me. So, as far as kind of studies there are out there, so for statistical studies, they're what are called observational and experimental. Observational sounds like you're just watching, and that's true to some degree, but just watching could mean actually doing measurements. It could mean counting. It could mean a variety of things, okay? So it's not just, doesn't mean just necessarily watching with your eyeballs, not doing anything, okay? So for instance, it could be, does eating before you go to bed cause you to not get as much REM or REM sleep or whatever? Well, I don't know. So what would you do? Well, you'd have people eat and not eat, right? Probably I wouldn't force them. I mean, maybe I would. Maybe I have people that come to my study that want to be in our studies, and so this group over here is going to eat before they go to bed. This group isn't going to eat, and then I can just sit there and watch them sleep. Obviously, I have to measure how many hours, in some fashion, how many hours they were in bed for. It could be a lot of things like that. But again, I'm not really doing anything per se. I'm just kind of watching what they do as a general rule. If I force them to change their diet or what their behavior is, then I'm doing an experiment. If I'm just observing, it's not the same. So, for instance, experimental is me changing something. So this could be an example of me changing something to see if it has an effect. effect, 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 effect. Nice. So up here, this is the idea. You could picture yourself sitting on a street corner, okay, and watching the number of cars that go by that like run a street stoplight and see if the color has anything to do with it. Okay, that's a dead giveaway. Other things, you could talk about, hey, these people here, these are smokers, these are non-smokers, and do they have more gingivitis or something? I didn't make you smoke. I'm just seeing if you have more gingivitis. Okay, so that's observational. How do I observe that? Well, I got to sit you in a chair, prop your mouth open, and poke around in there, and I, inspect it. Maybe do some measuring with the little tool that they use at the dentist office or whatever. But actually see what's going on. I didn't change your behavior. Down here, let's say hey, do you want to be in my study? Sure. What are you going to do in our study? Well, you have warts, and so we have this new wart cream. Okay, so put this new wart cream on and see if it, kills the warts, right? So we put something on, we want to see if it has an effect on the wart, obviously. The big deal, but the big difference between those two is observational. For the most part, is I can't change that. I can't change the fact that, all right, and it wouldn't be ethical to say, here, I want you to be a smoker now, start smoking. All right, that's weird. So again, to some degree, it's the idea of they're in a strata, they're already in there. Now I'm just going to watch what's happening. That said, I could pick smokers out of a crowd, okay, because I want to get a bunch of smokers in. And then I say, all right, now I want you to do this to see if that helps you to quit smoking. Okay, then it's become an experimental situation because I'm having them try something, this Chantix or something to kick the habit. Okay, and so the kind of studies we've talked about a little, we will talk about a little bit of the idea of controlled study. The idea that here these group of smokers are going cold turkey. These guys are getting this new gum or new patch or something. And we want to see if there's a difference based on from here to here. Obviously, if a higher percentage of the people on the gum can kick the habit than cold turkey, then gum is a good way to quit smoking. If it's about the same, that says that gum's no good. All right. Otherwise, what happens is like I know one person that quit cold turkey, therefore cold turkey is the way to do it. Or I know one person that used the gum, and no, what we need to do is not have anecdotal evidence or anecdotal study feedback. We want to have real feedback that says no. In fact, we compared them, and a way higher percentage of people on gum were able to kick the habit than were people on the cold turkey. So it's a controlled study. A couple other things you'll hear is the idea of a blind and a double-blind studies. Okay, so continuing with our control group and our treatment group, the ideas of, so we got a treatment group and a control group. Do the people know which group they're in? Well, in the course of gum and cold turkey, yeah, obviously. But in the case of, hey, we want to give you this new drug to see if it cures a cold. Okay, so cold, these people all have colds. These guys get the medicine. These people get a placebo. Now, of course, a placebo is just a fake cure. Obviously, it's like the idea of a sugar pill. Just to throw this out there, in statistics, you cannot do this with, for instance, cancer drugs. Okay, something that's life-threatening. What you can do if you want is you'd have two different treatment groups. You'd have the old treatment versus the new treatment to see if the new one's better. But it's not ethical not to treat somebody. In the case of a cold, they're going to get better anyway. So whatever, you can give them sugar, you can give them whatever. So the idea being here is that it's not going to affect me one way or the other. Same thing with like a wart cure or something like that. I doubt I can talk my wart into going away just by thinking good, positive thoughts. But maybe. But when it comes to things that would kill a person if they left untreated, that's not ethical. Okay, so I want to stress that. That's kind of a big deal there. But the medicines would look exactly the same. And so the people in the study would be blind. I wouldn't know which group I was in. I don't feel very good, but the doctor's given me medicine, and I would think it's medicine if I was in both categories. And at the end of the week, or or 3 or 4 days or whatever, I feel better now. Okay, good for you. And we could actually get some ideas of, well, how long did it last, or did this medicine clear up your mucus, or did it clear up your nasal congestion, or whatever it happens to be. We'd be measuring. Okay, that's a blind study. This is patients only. Don't know. Now, obviously, that's kind of a big deal when it comes to medicine. Okay, when it comes to agriculture, I don't think plants know or care if they're getting a placebo. You with me on this? So, a placebo technically isn't really accurate to say that in that regard. Okay, the same thing would be true for education. It'd be weird to give a bunch of third graders a placebo way of teaching math. That doesn't even make sense, because you wouldn't be teaching them math. It'd be a fake way of teaching math, which doesn't even make sense. So it would be the old versus the new again, or fertilizer 1 versus fertilizer 2. Double blind is the idea that the doctors and patients, neither one of them know. Doctors nor patients know which treatment. And the reason for that is, especially in medicine, is the big deal, because the way that you respond to someone when you're giving them care also can play a part in how well they heal up. So, for instance, if you look at them and go, "Oh, you poor pathetic soul, I know you're on the placebo, so you're not going to get better. So I don't treat you as well. I don't have as happy of a face on my face every time I come in to see you." I tend to then, you actually introduce a new variable, and it's the variable of the treatment, the way that the people are being treated, and so that can actually cause them to get better or not get better, maybe even get worse. I doubt get worse, but at least not get better, based on the amount of care and the kind of care that they get. The classic example of this, if you've never seen it, is the TV show House. I used to watch that show a lot. Back in my day, let's say 10, 12 years ago, I took it as a compliment to say I was kind of like that House guy a little bit. But anyway, I was watching the show, and so the one doctor, what's his name? Foreman, was going to do a study on his girlfriend's sickness, okay, which is completely weird and unethical to some degree anyways. But then she got into his study, which is completely unethical, but whatever. And anyway, now that she's in the study, he is down there visiting her one day, and the IV tube is leaking, so he fixes it, and he gets some of it on his fingers. And so then he wipes it off, and he goes out and he says something to the nurse about it, and the nurse says, "Did it smell bad?" And the guy goes, "No, it didn't smell bad at all." He's like, "Oh, well, she's not on the real drug then." And then he switched her. Oh, I quit watching the show at that point right there. That's it, I'm done. I will believe a lot of stuff, but when you start screwing my statistics, that's it, I'm done with you. Okay? But the idea when it's double blind is I can't, as a doctor, specifically a doctor, I cannot change how you respond to medicine based on how I treat you. And that's kind of a big deal. We don't want there to be any extra variable. I want to know that whatever I see changes in you is just from the medicine. That's the only variable in question. Okay? And so those are some of the things we're going to be looking at. We will have a few minor, quote-unquote, case studies where there will be a little story that you're going to read. And you're going to have to talk about, is there a placebo? Is there not a placebo? Is this a blind or a double blind scenario? Does it need to be blinded at all? For instance, I don't really believe, for the most part, if I just want to know for my own personal self, does the Miracle-Gro or the Fred Meyer fertilizer do better on my tomatoes? Okay, I will make sure the garden's set up the same way. I got tomatoes set up here and a different set of tomatoes over here. I'll keep them the same brand in both. Same amount of tomatoes, same water, same everything. And I'll just put the same amount of fertilizer on both of them. Okay? And when it's done, I'll just measure it and be happy. But that's me because I want to know. But if I was in marketing and research for, let's say, Miracle-Gro or somebody else, and I had some kind of an axe to grind in there, I'd want to make sure, it's very tempting to try to screw with that data. Okay? It's very tempting to try to manipulate it, all right, in order to put yours out, make it look better. Some groups do it on purpose. Some groups do it because they're not too bright. Some groups are just lazy. But that's something you always have to worry about when you read a study. Who did the study? Okay, did they have any dog in this fight? Okay, is this something that they're going to make $1 zillion doing? Is there any reason why you may not believe it? Okay, but again, if it's just an actual person just doing a study, want to know what's up, does it work, does it not work? For the most part, you want to keep it as straight as you can there. So if I'm testing on tomato plants, I wouldn't blind it. That's just not what I would do. If I was in marketing for Miracle-Gro, then I would blind it, but only because I'd want people to be able to say, you cheated. No, but if I didn't know which one was which, then I couldn't really cheat, could I? Okay? I couldn't cheat. We put the same amount of fertilizer on. It was a blind study. At the end, we revealed the blind. Oh, look, my kind did the better job. Okay? From a standpoint of, again, from the doctors, you're testing some new treatment. You want to know if this treatment's better than the old treatment. Then, yes, it's double blind, so we control for all that. When it's done, if the new cure does so much better than the old cure, right? And so it's significantly better, the people live longer, they recovered faster, whatever it is, then obviously, why are you doing that? Well, you're trying to make money. You're trying to develop a new product. That said, you have to be able to back it up, and it has to be reproducible in science. And so you need to be able to go out there and reproduce this. So somebody else takes your drug and the other drug that you tested against, redoes your experiment, they should be able to retest that and show that's true. So it's a big deal that, people worry about, well, big pharmaceutical companies, ripping us off or doing this, that. Well, I won't argue about their prices, but I will say that when you're doing these tests, it's important that, there's a reason why these drugs were developed, because we needed a better cure. And there's a reason that they settled on the drugs they settled with, because they actually do the job. Okay? And so, everything else aside, as far as cost, whatever, there's a reason they went the way they did. Okay? And they ended up where they did. Okay? So, that pretty much covers section 5A. It's a little longer of a lecture than normal, and I apologize for that to some degree.